Science 101. I'm Kayla.
And I'm Danielle.
And tonight we are going to be covering the topic of heat and temperature. The four main topics we are going to be talking about are temperature, heat, specific heat, and phase change. To start off, let's get some information on what temperature really is. Our sense of touch serves as a qualitative indicator of temperature. So if you touch a coffee mug full of boiling water, that mug is going to feel hot. Ow! But there is also more to temperature than just describing an object as hot or cold. In general, energy must be transferred to or from a substance to change its temperature.
This means that temperature is proportional to the kinetic energy of the atoms and molecules. The energy associated with molecular motion is referred to as internal energy, which is proportional to an object's temperature. So as temperature increases, internal energy also increases, and the speed of the vibrating particles also increases. Secondly, it is important to understand the concept of thermal equilibrium. Imagine an ice cube dropped into a cup of hot water. After about 15 minutes, both the ice and the water will have the same temperature. This is called thermal equilibrium.
Now that you understand the concept of temperature, let's get to heat. Heat is a transfer of energy between two or more objects with different temperatures. Energy is transferred as heat from the higher energy object, or the hotter object, to the object with the lower energy, or the colder object. In the last example we showed of the ice cube melting in the water contained the higher energy, so the energy from the water was being transferred to the ice cube, causing the phase change or causing the ice to melt. It is also important to understand how the law of conservation applies to heat. Energy is neither created or destroyed in this process. The amount of heat released by one object should equal the amount of heat absorbed by the other. But this does not mean that the temperature change between the two objects is equal.
All substances have a specific heat. This is the amount of energy needed to raise the temperature of a 1 kilogram of substance by 1 degree Celsius. This is the reason why in the summer, sometimes, when you go in the pool, the water is colder than the air outside of it. The water has a higher specific heat than the air, so it needs more energy to heat 1 kilogram of water than it does the air. Let's look at an experiment with heat and a paper cup. So, as you can see, we have a paper cup filled with nothing but air. And when lit, it does indeed catch on fire. So now we have a cup filled with water, and when you light it, it will not start the paper cup on fire because the specific heat of water is higher than that of air, and it takes more energy for the water to heat up than the air, and it protects the paper cup, so it will not start on fire, no matter how long I hold it there.
Heat can be used to cool a glass of water.
Heat can be used to cook our food.
Heat can be used to heat a house. Underground there are pipes placed, and a fluid circulates through the pipes. The fluid absorbs energy from the surrounding earth and transfers this energy to a heat pump inside the house.
Heat can be used to straighten your hair.
Thank you for watching Science 101. See you next time.
See ya!